So today we've got another realistic TRC1001. I was pretty scared because mind you, the strap's missing, which is frustrating, isn't it? Because you're not going to be able to always grip the range boost side panels properly. So the top screw-on bobble is missing, and when I started pulling up the antenna, I started to feel that the inner first element wasn't going to come out. Anyway, with some pliers and my super strong fingers, I have managed to get the first element to come out, because it'd be no good sorting this out and the customer not being able to use it because the aerial is too short and is going to destroy the transmitter. Perhaps that's what's happened to it. We'll find out. So of course we'll be testing. Oh, it's missing its grommet as well. You cannot run this without the grommet. We're going to have to mackle something up, because otherwise it's going to short against there for chassis. So not as so we're minus the strap, we're minus that. We did have a scrap AM one of these. It was available in the United States. We did have a scrap one. That doesn't mean it was free, but you can't use the telescopic aerial off it because it's centre loaded on those. But anyway, we'll sort the radio out, and at the end of the day, it isn't my problem that he's got bits and pieces missing and wrong screws in the bottom. I think this has been under somebody's bench for a very long time, and they've decided to sell it on. I don't think this customer's owned this from new. The other thing is, when we open it up, will it be the early version or the late version? The late version has got the variable power preset, and the early version hasn't. So battery condition, looks like it's 1983. So it does have some corrosion in here. I'll just go over that with the fiberglass pen as a courtesy. I don't actually check things on batteries. Again, at the end of the day, this is a trade repair only organisation, and the supplying shops are supposed to do all these first aid type of things. So I appreciate this is an end user, but I do expect people to be able to clean their own battery contacts. So we will be powering it from an external power socket. First of all, we'll unsolder the speaker. Oh yeah, it's got the variable power preset, so it's the later version. So these are a 12 volt radio, so don't go above 12.8, and that's been in the wars, hasn't it, with that drop damage. How can you bend the chassis like that? I suppose if you jack your car up on your walkie-talkie, perhaps you bend the chassis. Right, we should have a lead kicking around, so we can plug this into the power supply here. So as he says, the child display lights up. It goes out after 2 seconds, as it's supposed to. Press the little black button there, and it's supposed to come back on, but for some reason it doesn't. There could be a wire off. So he says there's no receive, no transmit. So we'll plug the test equipment into the extension speaker socket. So we have that, and we will plug the test set into the external aerial connector, wherever my adapter is. Oh, don't say the adapter's not here. Alright, so we've got the SO2392 RCA Phono stroke Motorola adapter. So the back of a standard car radio is a Motorola connector, or it was when there were car radios, which that goes into, or it also works as a phono. So let's put 2779125 on the signal generator. I've got my eye on the time as ever. I have got 7 minutes. We're going to be doing one of my sets next rather than a customer repair. I've got customer repairs, but we can't always do customer repairs. Some of the videos I want to make to help people, and we've got Midland 77104 UK coming up next. I think we've got an LCL communicator and i440DX early version, which is a customer repair after that. So, we've got the signal generator here. Oh, and it's working fine. Okay. So let's look at transmit. I'll switch picture in picture on. Put it on the 3 watt scale, and we've got 2.5 watts. So, the radio has presented itself working. Well, you know what? I don't think the customer sent it in working. I think it's as it's got bashed around in the post. I think it's repaired itself, which tells us it's a dry joint. And these radios do suffer from dry joints nowadays because of the double-sided printed circuit board, which is linked through. So we've got. We just zoom in on this. For example, there is a link. There is a link. There is a link that looks a dry joint. So what we're going to do is we're going to go through sorting out what are obvious to me potential dry joints. That's all we can do if the radio presents itself as in working order. There's another one down there. There's another one down there. But this is a situation where I can't show you a before and after because it isn't malfunctioning, but that's what will be happening. So I'll pause the video while I go through some of those. Right, I'll use a TRC1001 manual because it's handy. So I've gone through the dry joints on the top side. You can end up sometimes with dry joints on the bottom side. Because the radio's presented itself in working order, I'm not going to start going through taking all the shield plates off the underside, just on the off chance. Now I don't charge for dry joints, and the idea there is that if it doesn't work after 10 minutes, well, I didn't charge for it anyway. So the limit specification is 3 watts. It's a 3.5 watt radio. It isn't a 4 watt radio. So where were we? Let's go back into transmit, and we are. Oh, we need to up the voltage. We're at 11, so we'll set the voltage to 12.8. See what it's doing now. Oh yes, that's. It's doing 3.5 watts exactly. So it's already doing what the manufacturer says it is supposed to do. But we'll go through it anyway. So they have your. We're not going to go through the alignment of the phase lock loop because the radio's working. So we'll check it on channel 40. It's transmitting on channel 40. We'll check it on channel 1, and it's working on channel 1. It's slightly low on frequency. I'll show you that. So back on channel 20, it should be 27.79125. It's 79093. Now, I've only had the test set on for 20 minutes, and it needs to be on half an hour before we start setting things with any accuracy. So when I'll leave this radio on, I'll leave the test set on. I'm going to go do a Mrs. Thingy's shopping, and when I come back, I'll go through that. So we don't need to go through the alignment, but we do need to set it. So I'm going to have to take that little can off and do that. So on transmit, it's L5. Let's see whether we can... The only difference between this and the 1001 is the display, to be honest. So... changes glasses because the print of the manual's smaller than what my eyes can cope with. So 5 L5. No, that's T5. Go over from the other end. 9, 8, T8, T7, T6, T5, and L5, which is so early in the stages I don't even know where it is. Anyway, it's immaterial. Right, we'll go back onto the transmit meter. Peak. Peak. I think it's the blue one for these. No, it's not the blue one. It could be the white one. It's the white one. Actually, that was slightly out. 3.5. 3.5. And we'll just check the preset, the power preset there. So it's at 3.5, and that's about, I think that's at full whack. So that's fine, that's exactly on the, absolutely on the money. So let's look at deviation. You usually end up with these at full, to be honest. Wallow. On this occasion we're turning it down slightly. So the deviation is VR1. So get the little oscillator out. Wallow. Wallow. 1, 2, that's it. Interesting. Oh, it's a squelch. I thought it's slow going back to receive, but it's actually the squelch. And VR2 they want you to... Oh, it's VR2 is that one, isn't it? VR2. Yeah, so we've already covered that. Check if it works on low power. It's supposed to be 0.4 of a watt. It's not adjustable. It is 150 milliwatts. And they say it's supposed to be 0.25. Well, it's actually supposed to be 0.4. It says the government specification of the time. So they say 0.1 to 0.4. So at 0.15, we're getting on the money there. We're not going to check the second harmonic unless I think it's been fiddled with, which I don't. L12. When we do the scratchy corner test, we'll soon find out. That's the one you don't touch and then end up having to do it on a spectrum analyzer. So that takes us over to receive, and we will start, and then I'm going to disappear off and do Mrs. Thingy's shopping. And that's T4 for the best waveform. So we're going to put S9 signal on, like that. Take the bench light off. Switch the camera over to the oscilloscope. Find L4. That is L4. And we're looking, I'll just turn the volume down rather than the oscilloscope. And we'll just make sure we've got the best possible waveform. That was spot on. So I'll leave it at that. We'll switch the oscilloscope off. I don't know why we've got the screen of death on camera, whatever. What's happened there? Okay, so the camera decided it was going to disappear off. So we'll now put camera 4 onto there, and I'll see you later. We'll leave this on, we'll leave the test set on, and then we'll do the frequency. And ready for that, I'll just turn the radio off a second. We'll take this cover off. It's quite a faff to take off. It's quite a faff to put back on. Okay, so what I've decided to do, we'll now, a few hours later, we'll do the frequency. So I'll just go back on myself. Seem to recall it's the preset just there in the corner. Just check myself preset. What I was telling you about, it's a trimmer capacitor. TC2. TC2. So the other trimmer capacitor is to do with the VCO, which we've covered on numerous occasions. If you want to look at the back catalogue, if you need that. So we'll go into transmit. 2779112 is very slightly out. It's well within spec. Let's see whether I make it worse or better. So there we are, 2779126, just slightly above, that's ideal. I'm going to pop this cover back on, which will probably take me an eternity. I'll switch the power off while doing that. Right, that's gone on. We'll switch the power back on, go onto that synod meter, and let's see how we are with the receiver. So we're currently at S9, so we'll just drop that. And that's down to 1 microvolt. So at the moment, these aren't the most sensitive sets in the world, even though they're very good performers. We're doing 0.21 microvolts for 12 decibel cyanide. No, we're not. We're doing 2.1 microvolts for 12 decibel cyanide. And of course it should be much better than that. What's the limit spec? One microvolt for 10 decibels. So for 10 decibels we're doing 1.4 microvolts. So we've got to get a bit better than that, or we've got to find out what's wrong. So it's transformer 4. We've done that, which was done with the oscilloscope. So it's T1, 2, 3 and 5. So just find where those are. Change his glasses. So that's 5. So avoiding L12, which is the one we would need to do with the spectrum analyzer. 1, 2, 3, 5. So 1, 2, 3, 1, 2, 3. There's the crystal filter, and 5. So we'll drop that to about 4 decibels. So that's 1, slight improvement. Drop the attenuator. We'll have to go on the next scale. Always like it when we go on the next scale. It means we've made an improvement. We'll check that with a bigger signal. Go back to a small signal. Check that with a big signal. And then the final one. Check that with a big signal. Let's see where we are now for 10 decibels. Well, looks like we're at 1 exactly. So if I go on the fine scale, I'm at 1.2. So it's still just that tad away from spec. So I'm going to go through it again. See where we are now. See, I can hear, that's 0.3, 0.2, so it can certainly hear alright, it's just with the noise. Let's change scale. It's 1.1. 1.1. So it just doesn't quite meet spec. It clearly isn't faulty, but because there's some noise with it, it just isn't kind of hitting spec. So it's not going to affect the range, because we can still hear right down to, as I say, 0.2 of a microvolt. So it's certainly transmitting up to spec. That receives just that smidging away. And there you go. Right, we will screw it back together. We'll just turn the power off while we do this. Just a bit of wire there, which we'll do without. Oh, you know what? We never looked at this PTT switch, did we? Yeah, look, there's a wire off. Now, when we actually do repairs, it brings it into another tariff from the retune and test fee. But we're not going to implement that on this because it's so simple. So we'll just put it down on the job sheet as retune and test. Right, power the set back up, and now we'll press the little button, and yes, we've got channel display back, so that's great. So we'll go back to what we were doing, which was trying to solder the speaker back on. Of course, these wires don't get any longer, do they? Just chop that little end off. I'd like to have redressed this black wire, but I don't want to shorten it. Now that's an awful looking joint. I think it's had the plumber's solder on that one. Right, check it works on its own speaker. It does. And we'll get that put back together. So the big screw there. They're not domed screws in this bottom, they're flat. And both of these are domed as if they've come out of the side. So, I don't know whether somebody's had a row of this and they've kind of put the wrong screws in the sets. And talking about that sensitivity, of course we are losing some power in this adapter. So what I'm hoping, we're either going to have to push some self-amalgamating tape round that to insulate it. I will have a look and see whether we've got the correct grommet on a scrap American set. I do know there's one in my shed, but that's something we'll do off video. We're not here to test it on its aerial. We're going to be testing it through the external aerial socket when we do the scratchy corner test with Mr. Chippy. So to conclude this video, we'll put it on the external aerial, switch off the test gear. Oh, do you know what? I haven't had picture-in-picture on, have I? And that's my fault this time. Sometimes we do these to external mic, and when we do, people say the internal mic actually sounds better, which is fair comment. I'm not sure whether we've got one lying around today, but we sometimes have. Right, let's go through the channels. So when the meter on the top, just make sure we're on channel 20, we are. The meter on the top shows the battery status. So we're on external power supply 12.8 volts. Remember, you don't use these on a car cigarette lighter without using a dropper. All you need to do is to put a cigarette lighter connector with 3 diodes in series so that it drops enough to be no greater than 12.8 volts. These are not a 13.8 volt radio. It's very important to get that across to everybody. So standard realistic wiring on the 5-pin DIN external speaker sockets. It's a speaker, sorry, start that again, external microphone socket. It is not a speaker mic, it is a microphone only. Speakers there, charger, external power. We're in low power, flick it to high power. When I press transmit in high power, the meter will go across showing relative RF, bang straight across. And in low power, press transmit and it hardly moves out of the red zone. There is not an S meter on these radios, so it's in receive it's battery status, and in transmit it's relative RF. Well, these people are going to be about 35 miles away, so I'll still go 19 Roger. And unless I don't expect they're doing 4 watts. Let's set the squelch. Okay. That got rid of them, didn't it? Just make sure we can break through the squelch. Well, we're going to find that out anyway in a moment. It's not something I tested on the test set. It's not adjustable, but I really should have tested it. So we'll just make sure it works. And it does. But we'll be seeing that on the air test. So there we have it, another very nice realistic TRC1001. Supposed to be no receive, no transmit, and no squelch operation. I've gone through it for dry joints, but with it presenting itself in working order, that is a difficult task, because all I can do is to draw on experience and go through those plated through, not plated through interboard connectors. So we've had it on all day. I started this video at 9 o'clock. I went through it immediately for dry joints. It's now 7:30 in the evening, and this radio has not played up at any point during the day. So I can't do more than that. What we will do is tomorrow I'll switch the set back on and we'll make sure it's still working. So there you have it, a realistic TRC1001. It's the 1981 model, but this particular one is one of the late production from 1983. Thank you for watching.